grown so strong in these years. Every new processor has 64-bit, but the problem is the applications and kernel doesn't want to keep up with the pace. The same example with Windows, it doesn't have much drivers under 64-bit, but Linux is developing nicely under 64 too. With MenuetOS 64, it was mostly redesigned. Only the 16-bit parts remained the same. And most of the code was written purely because in 64-bit there are some limitations of the instruction immediate length, like you can't have a D-word instruction, you must first move it to a register and then call it by a register. And these kinds of changes, which totally changed the politics of writing the code for 64-bit. And it has a new driver programming API, which is really convenient. And it comes with default drivers for AC97 sound, NE2000 NIC support, and
Madis, can I ask a question?
yeah, of course.
Well, before you leave MenuetOS 32, I know you're going on to the 64, but you mentioned the 32-bit version, and I just want to comment that I think back when Ville started this stuff, one of his ideas was that the reason why it was convenient to have it on a floppy disk was to access smaller devices, smaller than the desktop computer, that were using embedded x86 architectures out in the field somewhere.
Yeah.
And for that kind of device, I don't really see why a 64-bit version would be useful. I'm curious to know your response to that.
Mm-hmm. I will come to that pretty soon. Of course, 64-bit doesn't provide you with much performance-wise and much better support, but the memory limits are now open, though there's no problem with MenuetOS size operating system. The most critical part that has changed is that with the 64 bits, okay, first you have the backward compatibility, so every 32-bit should run on it, but as you said, the old ones and the smaller ones you had to access. Now 64-bit doesn't concern these because 64-bit is a totally different architecture, and you can still use the 32-bit one on these with the little memory like 32 megabyte or down to even 16, I think was the minimum requirement. But what you can do with 64-bit, you can pretty much throw away all the old stuff. When you're writing code for 64-bit, you can assume that it at least has streaming extensions too. It's even for the AMD processors. I've researched that none of them came without it. The first 64 bits from AMD came with SSC and SSC2, and from Intel there's also SSC3 supplemental, and probably in 2 months they will come with the SSC4. So you can assume easily that you can write SSC code anywhere. You don't have to make compatibility code. So there's much less code than with 32-bit, where you need to discover whether it's 386, 486, has it got MMX on it. The range is so much larger with the 32-bit. You can start from the 386, which was the minimum that Ville said, and go up to the latest processors, even the Core 2s. But 64-bit narrows it down to only the first 64 bits up to the modern one. So I think the less programming work you have to do is the best feature of 64-bit. Not the memory requirements, because 64-bit programming usually requires you to write larger code. All of the memory access is 2 times wider. Though there are some optimizations, like writing to 32-bit clears the upper regions and other stuff that AMD invented.
But maybe I didn't make myself clear. I'm sorry. If my
Okay, please try to rephrase.
Yeah. What I'm trying to say is the original impetus for developing Menuet, as I remember it or as I understand it, maybe I am incorrect, please correct me if I'm wrong, was not specifically to provide a desktop computer operating system primarily.
Yeah, that's correct.
It was rather to offer a desktop operating system if one wished to have it, but primarily to focus on the smaller devices that were out in the field, embedded devices, and to provide a modern 32-bit operating system for those smaller devices that were running off a 386 or its equivalent, embedded. Now,
that is only partly correct. It wasn't the primary cause of writing this, but okay, it started out as a hobby just to prove a concept that this works and you can have a graphical environment in assembly under VESA and other restrictions. But they came to realize really quickly that it's also very convenient for embedded devices. But it wasn't the first priority.
well, I guess what I'm trying to say is that in my mind, maybe not in reality, but in my mind, the new version is completely useless for all of those devices out there in the field that are using the obsolete
That is correct.
architecture.
Because 64-bit cuts it to some part of time where all the old is obsolete and all the new is usable.
Yeah.
And that is why there are still many MenuetOS 32-bit fans, because one part is that they can't use it because they don't have proper hardware, and the other is that they don't want to use it because it's not backward compatible this much.
Well, then the question arises, of course, what is the intended goal or the intended purpose of MenuetOS 64?
The future.
Well, yeah, but you have to be very precise. You're talking about the future with desktop computer, because who is going to bother to build a 64-bit CPU for embedded applications? You know, you got a toaster, and the toaster is going to, you push the button and the toast toasts, but you know, do you need a 64-bit CPU for that?
No, you don't need
Right. So the home alarm systems or the smoke alarm systems or whatever it is that they're using these embedded CPUs for in modern construction of offices, houses, hospitals, whatever, they're not going to be putting Core 2 Intel CPUs into those applications.
But actually that is already partly fixed, because all the new intelligent home computers you buy have at least Core 2s inside them. And you can get a Celeron with $74 or something, which includes 64 bits, and it works with Menuet. That's the cheapest end. You can of course spend hundreds of dollars on a CPU, but in the lowest end, actually you can't buy a CPU, x86 CPU today which doesn't support 64-bit, whether it's AMD or Intel.
For a desktop application, but I'm talking about embedded applications.
Embedded application.
Yeah, for
But
embedded.
MenuetOS never was meant for embedded applications. It's possible, but now with 64-bit it's only possible with the 32-bit, as you mentioned, but 64-bit for embedded becomes a reality in a pretty near future, because the new devices you buy for your intelligent home or whatever have at least 64 bits inside if they have an x86 processor. It's not an absolute truth, but it's becoming a reality that MenuetOS 64 can also be used for embedded devices.
Well, let's move on a bit. There's a question from Hydruk. He asks, is there any possibility that you could take some drivers from Linux and port to Menuet to support some of the devices that are supported right now?
Everything is possible.
I use completely different driver names.
I've tried to look at the Intel gigabit and Ethernet drivers, which should be pretty easy. But the problem with Intel drivers is they're so big that I can't extract the critical part of it, which makes it work.
Yeah.
So I have to read through all that and go back to history where the first versions were made, and it takes a lot of time. With the new driver API, it should be really easy because there's only like a peek and poke. You pull and you can write to it. The principle is very simple, but a driver in the Intel gigabit Ethernet grade, it's really hard to do, and it might take a few hundred of kilobytes for a driver.
Yeah.
Like the old NICs, they had some 3,000 bytes or something that driver already ran. But to find the critical part that only sends and receives the bits to get the basic works done, it's really a hard job. But of course, one might argue and try to develop one driver. We would be very thankful.
There's a lot of support for advanced features in some of those later Intel drivers.
Yeah.
So it takes a long time to read through all the C code and the header files and to extract all the necessary port numbers.
But the good thing is that Intel provides hardware specs for its gigabit Ethernet and 110 backwards, but it doesn't provide hardware specs for its wireless drivers. It only provides free Linux drivers, but no specs. You have to read from the drivers how to contact the hardware.
Wireless is a big problem because they have some firmware code that needs to be loaded as well,
Yeah.
and they do not want you to.
So the Ethernet was my best bet to start digging some ground and look what happens. But I ended the search pretty quickly because I understood the code base was so large that I couldn't handle it myself. So maybe take a group of people and they can do it, or we can find a hero who does it for us, but it's a big problem.
Are you talking about the transport layer alone? TCP/IP or?
TCP/IP is done in a kernel just to get the most basic bits running. You can just tell the LAN card to send something and to receive something. One packet, one bit, what's the most basic part of it? So we can grow from there on and see what's the critical part for Menuet to work. Because sending and receiving bits might not work. It's just a principle of proving that this driver might work, so you can grow some fat driver around it that does the dirty work of TCPs and UDPs. So it's possible, but hard. It's assembly, and it should be hard, but let's see what the future brings. Now we got only two little developers. There was some 4 or 3 active developers last time I checked. And the last row says that new drivers, but still very little to be useful. I don't mean that it's totally useless, but you can't expect to take a MenuetOS floppy, put it in, and everything works. There's a lot of manual job and a lot of compromise. So how do you call it when it's working, when it's half working, or where do you put your line? And I've tried to help Menuet since, I don't remember anymore, 2003 or something. I mostly did the optimizing part. Ville usually codes it and it works, but I'm the optimization guru and I always try to fix something to get it faster or fit it in a smaller code space. But with 64-bit I did some coding too. I wrote new algorithms for pixel writing, reading, line drawing and ellipse, which were included in a graphical part of the kernel, and now they have function calls for them. And we also had SSC support. There was a long time when it only supported MMX because of the FPU state saving, which means also MMX because they use the same unit. But SSC was a bit harder because you need 4 kilobyte of space and it must be aligned by 60-byte boundary, and there was it was hard to find a place in the kernel where you could save it and read it so that it doesn't mess up the table of saved states, and it had like 8 kilobytes of data randomly, and I could manage to find one place where this 4 kilobyte could be set and aligned on a 60-byte boundary, and I posted the code, and there it was in the next release. So now we have SSC support for all the future processor, because whether it's supplemental SSC 3 or 4, it still uses the same amount of registers. But the next step will be when the SSC registers are double wide. I can't remember exactly when will it be introduced, but they should be 256 bits in the far future.
They already have plans to do that?
Yeah. Okay. Intel has said it has plans.
A funny little side remark is that you can't use SSE under Windows 9X either, because it doesn't support the
state saving, yes. You can use it, but you must always try to save it and use lock operands maybe.
Yeah.
It's very complicated.
You
but
clear the interrupt, the enable instructions to avoid it being interrupted, and then it probably works, but it's not so plain.
And now we come to the Colibri operating system. It's popular MenuetOS clone, which is derived from the 32-bit, and they are, I think, still at war with Ville, but it has somewhat cooled down. They did some nasty things with it, but the good thing is that it's being heavily developed with many new programs, many kernel fixes. There are, I don't know the exact number, but I guess there are up to 100 active programmers who develop it daily. I've watched the CVS, or did they use some other versioning control? They updated the daily basis, I think, or even half-day increments, and it's coming on pretty nicely. And most of them are Russian developers, I think. The forum is in Russian language, and
for a while they were talking about having an English language version. Do you hear any more about that, or is that dead in the water?
they have a translation for both, I think, and it's dynamically switchable. But the problems still remain that some programs are written by only Russian developers in only Russian, and even if you have a dynamic switch in the kernel, everything you see in the desktop changes to English magically. But this one program doesn't have an English version inside, and they still show you Russian letters that you
What
might
is-
not understand.
What is the main problem there about being in disagreement with Billy's opinion? What's that all about? What do you mean, the 32 with 64 compatibility or
No,
not?
they didn't want to hold on to the license agreement. But I don't know how it settled in the end, but there was one or two persons that really had a strong argument about. I hope it's settled now and it's peace, but who knows? The problem with 32-bit OS MenuetOS is that they have heavily changed the kernel and introduced many new APIs, and so programs written for newer Colibris won't work on Menuet, but the other way around it works. But as soon as they change some API to do something else, that's another world. Let's hope they at least be backward compatible with MenuetOS 32. Let's continue on the interesting parts. And the last news were the function 122 that Villa put in the Menuet. It's the 64-bit part now. He demonstrated a 3D application which was based on ray tracing, and then he thought that, well, let's put it in a kernel, and now it's you call a function 122 that does all the calculation for you. You just give it a 3D world, and it calculates every pixel on screen. And I haven't tried it myself, but the demo program was really simple. I was sent with it. Scalable fonts. This is pretty old news. I think a month or so. There was a problem in 32-bit. You can't do a browser without scalable fonts, and now that they are, another world opens because fixed font is a bit old, even for graphical small-scale MenuetOS.
Does it support true type fonts? So it's
No, they are still pixel fonts, but they are scaled from inside the kernel. You can't scale them afterwards when you've drawn them. They are calculated to pixels and just put into bitmaps. There isn't a true type font. There was some ideas of implementing some kind of fonts, but I hope they're not dead, but it seems like it because I haven't heard any news about implementing.
You could port the free type library to Menuet, but it's rather large.
It was one possibility, the free type, yes.
It wouldn't be good for the standard distribution, I think, but as an option it might be a good idea.
And now that we think that most of the critical functions are there in the kernel, then we go to the applications. The best demonstration, I think, was the MSS, which is style sheet program, where you can already draw some graphs and calculate sums and averages, and it was really nice demo what you can do in assembly. I don't know how long he wrote that, but since the first mentioning, I think a week, and it was in the next distribution. And with the one version that's coming, I think it's a week away or something, he improves the MSS, the clock, the draw application, and upgrades the skin the Menuet has. That's what I talked about before. Why is 64-bit so good? We discovered it isn't good because we throw out the 32-bit part, but still we have compatibility with the 32-bit part in sense that you take a program written for 32-bit and it runs nicely on the 64-bit. It's emulated like in the Windows, and you can even mix the old interrupts, which was 14 in hex, with the new interrupts, which is 16 in hex, and they both work in the 32-bit world. Though if you make such an application, It works under 64-bit, but it doesn't work under 32 anymore because you use the new interrupts that weren't there in the 32-bit world. And the size pros and cons, which basically are the addressing modes. In 64-bit you have 8 bytes facing you everywhere, so sometimes you can't escape the larger code stamp. All the movements to 64-bit register use the rex prefix, which is 1 byte to every line of code, I think. So that's a bit bad, but 64-bit kernel is right now some 73 kilobytes, the last one, as I remember. Though it has started a long time ago, it's still starting, I think, to grow, because all we need is some good developers, and we can make miracles. With this one-man band, you can't reach very far. So it's already starting to take some nice shape that I personally like. Maybe some have counter-arguments, but it's the way I imagined it a few years ago when the first .01 version of 64-bit MenuetOS came out. And what we need is, of course, more drivers to be able to run it just by putting a floppy or a USB stick in and boot. But we need user-friendly approaches and techniques. I think I need to explain it a bit more. Right now, most applications have a GUI, but there were some ideas of implementing some command line interpreter. In Colibri it exists, but in Menuet it isn't official. There are some test applications that work with some commands, but it would be really helpful if you could use your keyboard rather than your mouse. Mouse is really inaccurate, and closing your application with the X in the corner is a bit slower. So that is what I mean with the user-friendly approach. You can close your application, for example, with Escape and Alt F4, like in Windows, and it shouldn't be made by the programmer who makes the application, but rather from the kernel side, that you choose which events you want to close or resize your application. Right now it's only possible with mouse. And some more cosmetics things that we could do, but that's pretty much it. I won't bother you anymore today.
Well, what does Colibrios also use FASM?
Yes, it's fully assembly.
So
written.
really, all 4 of the existing alternate operating systems, that means Menuet, Colibrios, Dex is DOS,
Yeah.
and Bogdan's Sol. All of them run off FASM, right?
Yep, exactly.
So I think that's something worth, letting people know. That
Yeah.
strikes me as being something pretty significant.
There's also Octaos, as I remember.
But but he's got his own. No, but
He's got his own.
he's got his own assembler.
Yeah.
He's got his own syntax and his own assembler.
I can't recall. Did he write?
You're talking about Octavio, right?
Octavio,
in
yeah.
Spain. Yeah. He's
Did
got
he-
his own. He's got his own syntax and his
Even
own
his
assembler.
first operating system was on his own syntax, not FASM.
I think his first one was under FASM.
Okay,
But
but
the one that he has
converted.
now, his
Okay,
more advanced one, is with his own assembler.
so FASM was a